4.4, permutation when objects are identical. Yesterday, or the last lesson that we talked about, was permutations when every single object was distinct. I think the word that we used was distinguishable. There was no repetition. Well, what happens when we have some objects that are repeated? So let's just look at this this example involving prayer flags. So in the mountainous regions of India, China, Nepal, and Bhutan, it is common to see prayer flags. Each flag has a prayer written on it, and the color is used to symbolize different elements. So green is for water, yellow is for earth, white is for air and wind, blue is for sky and space, and red is for fire. So the question is, how many different arrangements of the same prayer flags can Dory make using 9 flags? 1 green, 1 yellow, 2 white, 3 blue, and 2 red. So the total number of flags (1 plus 1 plus 2 plus 3 plus 2). That equals 9. So if we were to think about it in terms of our fundamental counting theorem, we would have 9 spots. And if they were all distinct, we could just go 9 times 8 times 7 times 6 times 5 times... Oh! You guys see the mistake I made here? That's funny. So, okay, 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So that just is 9 factorial. However, we can't just say that that is true, because we have these reoccurring elements. So we have 2 white flags, 3 blue flags, and 2 red flags. So if this spot right here takes up red flag number 1, and this spot right here takes up red flag number 2, the prayer would be the exact same if this was red flag number 1, and this was red flag number 2. So we need to take into consideration that some of these things are repeated. The way that we do that is we say, we're going to define A, so let A represent the number of distinct arrangements of flags. And I would say A equals 9 factorial over 3 factorial for my blue, times 2 factorial for my red, times 2 factorial for my white. Now I'm going to color it yellow, but that's the closest thing. And the reason why we have 9 is because we have 9 flags. So I can either just put this in my calculator and figure it out, or I can write it out the long way. So 9 times 8 times 7 times 6 times 5 times 4 times 3 factorial, because that is the most beneficial. So 3 factorial times 2 times 1 times 2 times 1. That's just the 2 factorial and the 2 factorial. I really don't need the 1, but since it's factorial, it's just nice to see that. So 3 factorial cancels with 3 factorial. 2 cancels with 2 and 4, but we're left with 2 up top. 2 here cancels with 2 in here, so we're left with 3. So my answer here is 9 times 8 times 7 times 3 times 5 times 2. And that is 15,120 different prayers.